Hello, folks. I like to do this in a series of short movie or video clips, and I like to target three different groups of folks: those who are just about to enter freshman year in high school, who has some knowledge in terms of algebra, but very little or none as far as calculus goes. The second group is for those who have studied calculus, who needs some sort of review to refresh or to improve on their technique. And third but not least is the group of who speak English as a second language. Hopefully, you guys can use math as a tool here to learn the language. Okay, so this is an exam that typical folks in Vietnam, I mean the last year student, 12th grade, takes in their school year. It's supposed to last 90 minutes, and it has 50 multiple choice questions. As you see, this is pretty time pressing, but it actually is pretty doable for a good student. You probably can get almost all 50, but if not all of them. Depends on how much exposure you already have as far as having seen a similar problem. The technique, of course, is for you to go through and do all the easy questions first, and then uh, tackle the harder questions toward the end. And I believe that for the majority of the 50 questions, maybe 80% of that should fall into the easy questions, meaning something that you can reason out quickly, or you have seen, and even if you have to compute, it should not take too long. And I believe that you can do these questions probably in, I would say, 30 minutes. And then you can leave the other full hour, 60 minutes, to take care of the maybe the 10 to 15 questions. And that leaves you about maybe 4 to 6 minutes per harder problem. Okay, so let's go ahead and dive into this. My approach is I am going to assume that you don't know much about the topics, so I'm going to go slow, and I will explain the basics whenever we encounter something the first time. Hopefully this thing will be okay with you guys. So the first problem or question is, let me translate that. The conjugate complex number of this number, which is z equal 2020 minus 2021i, is. Now, for some of you who have not learned this, a regular complex number, which is a number of the format a plus ib. I here is a unique label. You're not supposed to be changing that. It represents imaginary. So a complex number can be written in the form of a plus ib. A is a real number. B is also a real number. But written as such, IB is an imaginary number. The way it is designed is to address some of the more elaborate engineering or math problems later on. in the calculation of these complex numbers, you're not supposed to be adding the real part or mixing by adding the subtracting the real parts and the imaginary parts directly. Okay, so in general, if you have z equal a plus ib and you have y equals c plus id, when you add z plus y, you can add a plus c, and then you can add the imaginary part together, so it becomes b plus d. So now you have a new number. When you add two numbers together, you have the real parts added together, and you have the imaginary parts added together. And by the way, these numbers can also be written in a different format. And let me write it down here. A square plus b square, an angle, and I will call this one arc tangent of b over a. And likewise, this number, I'm going to go and write it down next after I explain to you what it means by this. This format has two parts. One is called the strength, meaning the length of the vector. And the other part is called the angle, or the phase of that signal. By the way, when you go into a graph to record a complex number, there are two dimensions. One is a dimension called real, and one is called the imaginary. Much like a regular xy, but here we call real and imaginary. And then for some number like z equal a plus ib, then you have on the real part, you go from the origin, which I call O, or sometimes we can call it 0, a length of a, which represents the real part of z, and then on the imaginary axis, we go a part equal to b here, and when we identify a point here, this point is called z, which has the value of a plus ib, whereas a is the real part and b is the imaginary part. It can also be represented by a vector, and a vector here has a strength of a square root of a plus b square. The reason for that is this is a right angle triangle. The right angle is here, and there is a formula called Petagorin. Actually, I'm going to write it as a Petagorin Theorem that says that in a right angle, the right angle triangle, let's call ABC, whereas the BC is called the base, which opposes to the 90-degree angle here. So this is called the right angle triangle. Triangle meaning tri mean three, meaning it has 1, 2, 3. So this shape is called the triangle. A right angle triangle is a triangle, meaning it has 3 sides or 3 peaks, but with a right angle, and that is called the right angle triangle, right? In the Petagorin Theorem, it says that this base here, opposing to the 90-degree, when you square that amount, it is equal to the square of AC plus AB, meaning the square of the base is equal to the sum of the square of the other two sides, meaning AC and BA. So therefore, BC, as you go from the square part to the regular part, you take what we call the square root. So this become square root of AC plus square root of AB. And then you put this, which is written as sort of like a V, but with a long roof. And this is called the square root. It implies that there is a number 2 here for square root. Later on, you may find some other form of root, like root, cube root, then there's a 3 here. Or root to the nth, then there will be an n written here. All right? So, so much for imaginary number z equal a plus ib, where the strength is recorded here. And then let me talk about the angle. In this notation of a complex number, it is described with the strength and with the angle with respect to the lateral axis or the x-axis. And this angle, if you call it alpha, in trigonometry, which we will get to at some point in time, the tangent of this angle, alpha, is defined as the opposing edge, which is, in this case, if I can say A to B, or the strength here, this distance here is actually the same as here, let's go B, over this side, which is equal to A. Okay, so the tangent of this angle is equal to B over A. Likewise, when we say what is alpha, we say alpha is the reverse of that, meaning alpha is the arc or the angle which tangent equal to B over A. Right? So these two are equivalent. One, you say the tangent is equal to a certain number, right? And the tangent of an angle. Or you can say the angle is, that is a angle or an arc which tangent is of this value. The reason why we say it's an arc is later we will talk about the true meaning of a trigonometric value, where we draw a circle with the radius of 1, and when you have an arc, this, it means this is the arc, or within here, this is called the angle, but the length over here is called an arc. The arc span from here to here. The two are similar, interchangeable, but you got to understand, sometime when we mention the arc, we actually mean the length of this. And here we only talk about the measure of the angle. And the measure of the angle can be in degrees, in which the whole circle here is 360 degrees, or 2 pi radians. The two are equivalent. In math, you often use degrees or radians. In engineering, most likely you end up using 2 pi. And pi here is a special notation for a transcendental number, which means you cannot write it down completely. And it starts with some number like 3, 1, 4, 1, 5, 9, and so on. And people have calculated this number out to probably million of decimal digits, and it still does not end, and it probably will never end. Okay, so this is called a pi, much like apple pie, but this is the notation for it to be written in mathematical formula. Arc is often most likely to be described or measured in radian, much like the degree angle. And in this trigonometric circle, the projection of this arc, or this point here, down to this, and by the way, this axis is called the cosine of x. I write it here as cos. Sometimes we say cos or cos, but it's cosine of x. So when you project to this cosine x axis, this length here is defined as cosine of x. And when you project it onto this axis here, this is called sine of x, but we often only write sin, but it's actually is sin x. Okay, so, and then if you draw a line which is parallel to this sine of x axis here, but touching the circle, and what it means is it's tangent. You heard the term tangent. Tangent meaning a tangent conversation, meaning some conversation which relates to something. And in the mathematical world, tangent meaning a line that touches something. This line is parallel to sine of x. It touches the circle at this point. It's called the tangent line. If you extend this same line out to here, and it cuts this tangent line at the point, the strength or the length from this cosine x axis to this point is called the tangent of alpha. So we go back to this same thing here, where we say the tangent of this angle here is equal to the tangent of, let me switch color so you can see. The tangent of this angle is equal to this sine divided by this sine. Pretty much the same as here, because when we define here there's tangent, and we know the radius of this circle is equal to 1. All right, so we already talked about the trigonometric circle. We're going to go back to this at some time when we run into a similar problem. We talk about the representation of a complex number in terms of written as z equal to a plus ib, where a is the real part, b is the imaginary part. And we talk about the representation in terms of a vector where you have a strength, square root of a square plus square of b, and an angle, which we say this is an angle which has an arc, has a tangent of b over a, which is this over this, where b is this and a is this. Now, when we say a conjugate of a complex number, we simply change the sign that is the sign of the imaginary part. So let me explain. If z is equal to a plus ib, then the conjugate of z is equal to a minus ib. So the only difference is one has a plus and one has a minus. So this is called the conjugate of this other complex number. So the answer here is, all you look for is 20, 20 plus 20, 21. And that would be this. Let me end it here and go to the